So again, I'm continuing the work on example number 1, part 2, and we are asking for the derivative here. And again, how do you know whether you need the product rule or some other fancy rule? So the way to figure out whether you need the product rule or not is to look at what's in the middle right here. It's a little dot, which means it's a product. Are there x's before? Are there x's after? If the answer is yes, then you will need a product rule basically. If you have a constant first, meaning a number, so if I had like a 3 only right there, then I would not need a product rule. I would just use the constant multiple rule from the section 1.5. But in this case, I have 3x minus 1. So in fact, I do indeed need the product rule. So this means that we have to use a product rule. So let's go ahead and set it up as usual. And so this is going to be a standard kind of setup. I'm going to figure out who the first function is, who the second function is. Once I do that, I'm going to figure out the derivatives of each one of those functions and basically do my prep work. Once the prep work is done, I'm going to take my answers and multiply them and add them according to the rule. So again, the first function is the 3x minus 1. It's whatever comes before the multiplication. The second is going to be the 4x cubed plus x minus 7. That's whatever comes after the product. And the derivatives of each one of them will be 3 and 12x squared plus 1. So at this point, I'm just using the rules from section 1.5 to do this setup. And keep in mind that you're supposed to multiply starting from the 1 prime corner, ending with the 3x minus 1. So some folks just write this little thing without the direction. Just make sure, please, to put the arrow direction so that you remember which corners you're multiplying with which, because it makes a difference which corners you multiply and if you do the right order or not, especially when we start doing the quotient rule next. So now that we have all the things set up, let's go ahead and repeat. So the question said, find the derivative with respect to x of 3x minus 1 and 4x cubed plus x minus 7. So they want the derivative of this. And according to what I just found, I am supposed to multiply the 1 prime with the 2 and then add the 2 prime times the 1. So 12x squared plus 1 gets multiplied with a 3x minus 1. So again, the way we multiply is the 3 gets multiplied first with the 4x cubed plus x minus 7. Then you multiply the 12x squared plus 1 together with the 3x minus 1 that was originally there. So that's kind of how you multiply it. And at this point in time, that is already the answer. So if you put a box around this, you're technically correct. However, usually people want the answer simplified. So let's continue and simplify the expression by foiling everything or multiplying everything out. So 12x cubed plus 3x minus 21. And then 12x squared times 3x is going to be 36, x to the power of 3 minus 12x squared plus 3x minus 1. And let's see if there are any like terms. So there's a 12x cubed at the front with a 36x cubed in the middle. Together, that's going to be 48x to the power of 3. So that's basically out of the way. Let's do the squares next. We only have the 12x squared without any other like terms. So negative 12x squared. Next, let's take care of all the x's. I have 3x here and 3x there. So that's going to be 6x. And then finally, the 21 and the negative 1. They are like terms, so together that's going to be 22. And that is the end of the story. That's the derivative. So hopefully you got this one right. So again, I'll give you a chance to try the next one, and I'll give you the answer in the next problem. So with the next one, just be careful because you have to rewrite the square root of x as x to the power of 1/2, and the cube root of x has to be written as x to the power of 1/3. So you're going to have some exponents that are fractions. Oh well, it is what it is. But work it out, and I'll give you the answer in the next video.